We will talk about friction in detail in my next video. I think this much knowledge is enough for this topic. This is what I said in my previous video. So in this video, we are going to dig a little deep into the topic. The word friction is derived from the Latin word fricare, which means to rub, which I guess nobody cares about. So friction is often associated with two surfaces of solids in contact rubbing against each other. It is the force that resists the relative horizontal motion between these bodies. It exists because of the micro irregularities of these surfaces locking against each other. To understand this, let us look at the macro-scaled examples of these surfaces. If they are put against each other like this, and then some force is applied on one of them while fixing the other to make them slide over each other, we will see that the only force working against the applied force is the component of reaction force generated to counteract the component of gravitational force at that particular point. A general misconception about friction is that it depends also on the area of contact, but it is not the case, simply because mass is also distributed throughout the whole area, and so will be the normal reaction force to counteract the overall gravitational force. Which means friction is directly proportional to the normal reaction force only, and the proportionality constant is known as coefficient of friction, which is often denoted by the fourth Greek letter mu. The vector sum of the normal reaction force and the friction is known as contact force, with a magnitude as follows, and its direction can be determined by simply calculating the inverse tan for the ratio of normal reaction to friction. Friction not only works between a pair of solids but also between a solid and a fluid, or even a pair of fluids. Friction was actually the biggest hindrance in the way of first technological breakthrough humanity has ever made, which you know as wheels. Because friction often results into heating, which damages the wheel at the point where it is making contact with the shaft. How did they overcome friction? We will discuss it later in this video. This heating effect not only is a hindrance in the tech, but also responsible for making our sky beautiful. The meteoroids are actually frozen pieces of rock and metal moving into space at a very high speed. The moment they enter Earth's atmosphere, they start feeling air friction, and at that speed, they feel too much of it, which results into too much of heat, making the meteor burn away. And at the same time, we have an amazing phenomenon to witness. Friction is there in action even if there is a relative motion between objects, and such a friction is known as kinetic friction. Whereas when there is no relative motion, the frictional force is known as static friction. The kinetic friction on A has a direction opposite to the direction of its relative motion with B, and has a magnitude which is proportional to the normal reaction. The proportionality constant in this case is known as coefficient of kinetic friction, which is denoted by mu with a subalphabet k, whereas the direction of static friction is opposite to the direction of applied force, and its magnitude is yet again proportional to the normal reaction force. The proportionality constant in this case is known as coefficient of static friction. It is also denoted by mu, but this time the subalphabet is s. It was stated by a Greek scientist that it is easy to make a body continue its motion when already in motion than initiating motion in a static body, which may possibly be a glimpse of their understanding of the difference between kinetic and static friction, or it may only be a philosophical stuff. The coefficient of kinetic friction is generally less than the coefficient of static friction. So yeah, kinetic friction is also going to be less than static friction. You can look at this list to compare the coefficient of kinetic and static friction between different surfaces. This happens because of the inertia of motion, or because the dust particles in between them are already set in a rolling motion. So here we can develop a rough idea for the ways to reduce friction. One of them is simply by introducing something between these surfaces, like a fluid or some balls. You might have noticed that sometimes you slip on wet surfaces. This happens because the fluid occupies the space between your footwear and the floor, drastically reducing the friction. To reduce friction between different parts, of a machine, such fluids are created, and they need to have a lower surface tension and a high viscosity for optimum use, and are known as lubricants. When balls are introduced between a block and a surface, the friction is dramatically reduced yet again, and such a friction is called rolling friction. This, along with some lubricant, is used in most of the modern day wheels to reduce friction between the shaft and the wheel and are known as ball bearings. The coefficient of friction is measured using two different methods. One of them is known as horizontal table method and the other is known as inclined table method. In horizontal table method, a block made of material in question is kept on a horizontal table while attached to one end of a nearly massless string which passes over a smooth pulley. And on the other end of the string, another mass is attached which is gradually increased until the block just starts moving. Now the ratio of weight of mass at the other end to the reaction on the block, which is equal to mg, is taken. This gives us the value for the coefficient of static friction. To calculate the kinetic friction, the mass is reduced by a bit and the block is slightly pushed. At this point, the ratio is taken yet again, which gives us the value for the coefficient of kinetic friction. In inclined table method, the block is kept on a table with variable inclination, and the inclination is increased gradually until the block starts moving. At that point, the reaction force will be against a component of gravitational force and the dragging force will be another component of gravitational force. Now the ratio is taken, which is equal to tan theta, and theta is the angle of inclination. And this will give us the value for static friction between the table and the block. To calculate the kinetic friction, we simply need to reduce the inclination by a bit and push the block slightly. At that point, we simply need to calculate tan theta to get coefficient of kinetic friction. For the real-life scenario, the coefficient of friction is not constant throughout the whole surface, but close to a certain value depending upon how evenly the surface has been grinded. So yeah, I think that's it for today. See you guys in the next video. Till then, assalamu alaikum. Don't forget to like, share and subscribe if you think this video is helpful in any ways.